In this example, we have Na3PO4 and MgCl2 reacting to give NaCl and Mg3PO42 respectively. The first thing we do with the example here is that we rewrite the equation so that we can set random variables to them. So we have Na3PO4 reacting with MgCl2 to give NaCl and Mg3PO4 2. Let us now assign random variables to these reactants and products. So let's say Na3PO4 has A assigned to it, MgCl2 has B, NaCl has C, and Mg3PO42 has D. Next, we list the elements we have on both sides of the equation. So for this equation, we have sodium, we have phosphorus, we have oxygen, we have magnesium, and we have chlorine. Now that we have all the elements listed, we can form equation using the random variable. So for sodium, we have 3 sodium on the left side of the equation with Na3PO4, so we can say we have 3A. This will again be equal to the sodium on the right side. We have 1 sodium, and it's with NaCl, so we'll say 3C, 1C, or we can just write C. For phosphorus, we have 1 phosphorus with Na3PO4 on the left side of the equation, so we can say A is equal to, on the right side of the equation, we have 2 phosphorus because PO4 is in brackets and we have 2 at the bottom, which means we have to multiply the 2 with the P and the O. So for phosphorus, we'll have 2D. For oxygen, we have 4 oxygen on the left side of the equation with Na3PO4, so we will have 4A. This again will be equal to 8D because we have 4 oxygen with PO4, but then we have 2 of these, so we have to multiply it with 2, so we'll have 4 times 2, which is 8. For MgCl2, we have 1 Mg, so we can say we have 1B, or just B. On the right side of the equation, we have Mg3PO42, which has 3 magnesium, so we can say 3D. For chlorine, we have MgCl2 on the left side of the equation with chlorine, and we have 2 of them. So we will have 2B being equal to, on the right side of the equation, we have 1 chlorine with salt, or sodium chloride. So we will have 1C, or we can say C. Now that we have all our equations set, we can set one of the variables to be equal to 1. So, just like before, let's say A equal to 1. And now that we know one of our variables, we can start off with the very first equation we have. So we have 3A equal to 1C. We can rewrite this equation, so we can say that, so we have 3A equal to 1C, or we can say just C, which is the same as writing C is equal to 3 times A. Now that we know that A is equal to 1, we can say that C is equal to 3 times 1, which is equal to 3. Now we have both the values of A and C, so we can now look for B and D. If we go to the second equation, we have A equal to 2D, so we can use that to find our next variable. So once again, let's rewrite the equation. We have A equal to 2D, which is the same as 2D equal to A. And since we are looking for D, we will have to say that we'll have to look for D by dividing both sides of the equation by 2. So we will have D equal to A over 2. We know our value of A because we already set it in the beginning. So we know that A is equal to 1. So D will be equal to 1 over 2. Now we have A, C, and D. We only have B left to find. And we have already used up the first equation with sodium. We have used up the second equation with phosphorus. And now we can do the third equation, but that would be double checking because we have already found A and D. So let us not do that one for now. We can do it for double checking, but we will not do this equation. We move on to the next one. We look for an equation that has B in it because that is the only variable that is left for us to find. We have magnesium with that equation. We also have chlorine with that equation. Now, we can choose any one of these equations to get our answer, and then the one that we choose is the one that will give us the answer, and the one that we don't choose can be used for double checking purposes. So let us choose the easier one for now. Let's choose B equal to 3D. So we have B equal to 3D. We know that D is half, so we can say that therefore B is equal to 3 times half, which will give us 3 over 2. Since we have our values for A, C, D, and B, we can now plug back our values into the equation. However, for this example, it seems that there are fractions for some of the variables. So for B and D, we have half and 3 over 2. This is usually acceptable, but people prefer to use whole numbers as coefficients instead of fractions. Hence, what we can do now is that we'll have to multiply all the variable values with the highest denominator we have between A, B, C, and D. Since the highest denominator in this example belongs to B and D, we will multiply that denominator with all the random variables. So far we have A equal to 1, B equal to 3 over 2, C equal to 3, and D equals 1 over 2. So now that we have to multiply 2, which is the highest denominator we have so far, and it's found in both B and D, we'll multiply this number to all the values we have for the random variables. So we will multiply A by 2, we'll multiply B by 2, and we will multiply C by 2, and we'll follow the same for D. Doing that will give us the value of A to be 2, value of B to be 3, the value of C to be 6, and the value of D to be 1. Now that we know the values for all our random variables, we can replace our random variables with these numbers as our coefficients for the equation. So for our equation, we will have 2 Na3PO4 reacting with 3 MgCl2 to give 6 NaCl and 1 Mg3PO42. our equation, we can double check our equation, but this is the right answer. And our equation here is balanced. Let us move on to a different example, which is even more complex. The next example is probably one of the hardest ones one can ask for balancing equations, but we will see how we can use the same approach to solve even the hardest possible questions in balancing equations.